Here is the anomalous nature of fluorine we are going to discuss. Fluorine is the most reactive element among halogen. This is due to the minimum value of fluorine and fluorine bond dissociation energy. It can dissociate immediately. Fluorine decomposes cold dilute alkalis, liberated oxygen difluoride, and with concentrated alkali, oxygen is liberated. You can see the reaction here. Under similar conditions, the other halogens will give rise to hypohalides and halides respectively. The greatest affinity for hydrogen forming hydrogen fluoride, which is associated due to the hydrogen bonding. Hydrofluoric acid is a weak acid, whereas the other hydrohalic acids are considered as very strong acids. The other halogen in that it can form two types of salts with metals, sodium fluoride and sodium hydrogen fluoride. You are able to see it here. The salts of hydrogen fluoride differ from the corresponding salts of other hydracids. Silver fluoride is soluble in water while the other AgX are insoluble. Being strongly electronegative, it can have only a negative oxidation state, while the other halogens can have negative as well positive oxidation state. Hydrofluorine attacks glass while others do not. Fluorine, because of the absence of d orbitals in its valence shell, does not form any polyhalides. I am trying to show the sodium hydrogen fluoride here. Thus, we'll be having I3 minus, Br3 minus, Cl3 minus, but there is no F3 minus ions.